For millennia, the Klamath, Karuk, Hupa, and Yurok tribes fished, hunted, and harvested in the Klamath River watershed. 100 years ago, salmon thrived in the upper and lower basin and were important to all four tribes. In the upper basin, freshwater chwam and kapto, also known as suckers, were important to the Klamath tribes. Beginning in the 1800s, successive waves of European Americans began to transform the river. Spurred on by the Industrial Revolution and developing technologies, mining, logging, ranching, farming, commercial fishing, and the production of hydroelectric energy became important industries in the basin. While these industries helped build the wealth of a young nation, they dramatically changed the Klamath River watershed. Students studied these impacts on the watershed. Mining. From the mid-1800s into the 1900s, gold miners diverted creeks, leveled hillsides, and washed away gravel needed by spawning salmon. Logging. Timber harvesting practices, such as poor road construction and clear cutting, led to soil erosion and destruction of the forest canopy that shaded and cooled the river. Dams. Between 1908 and 1962, 4 mid-basin hydroelectric dams were constructed to provide power to farmlands and towns. Dams block the passage of spawning salmon to some 300 miles of habitat in the upper basin. This map shows where salmon once spawned. Here are people catching salmon on the Link River just below Upper Klamath Lake before the dams were installed. Klamath Basin students studied these 4 dams. Today, these dams provide clean, renewable energy to 70,000 homes. However, these dams do not provide irrigation water nor flood control. Farming, ranching. Farming and ranching affect both water quantity and water quality. In the United States, to grow crops and raise livestock for food, agriculture uses about 80% of the fresh water consumed. The natural quantity of water in the Klamath River watershed is decreased by 5 major agricultural diversions from the Klamath River and its tributaries. The following approximations are for conditions of average water availability. In the upper basin, the Bureau of Reclamation's Klamath Irrigation Project also supplies water to wildlife refuges. The project diverts about 400,000 acre-feet of water from Upper Klamath Lake and the Klamath River. An acre-foot is the amount of water it takes to cover 1 acre, approximately a football field, to a depth of 1 foot. Upper Basin off-project farmers take about 420,000 acre-feet of water from rivers and Upper Klamath Lake. Shasta and Scott River farmers, with some 87,000 irrigated acres, take at least 100,000 acre-feet from their rivers. The biggest agricultural diversion of all, some 600,000 acre-feet, is the Bureau of Reclamation's Trinity River Diversion that sends water to California Central Valley farmers. The smallest diversion is about 30,000 acre-feet sent to Oregon's Rogue River Valley. In the Upper Klamath Basin, wetlands were drained to create farmland. Since 1800, about 1/3 of nearly 500,000 acres of lakes and wetlands were drained. Draining wetlands for agricultural, urban, and other human uses decreased available water by decreasing water storage. Draining of wetlands and breakdown of stream banks decreased fish habitat and water quality. algae. AFA, or Aphanizomenon floss aquae, is now the dominant blue-green algae of Upper Klamath Lake. Long ago, volcanic phosphorus became the nutrient that fed overproduction of several types of algae. AFA was most likely introduced to Upper Klamath Lake over the last 150 years, perhaps aided by human activity. Bacterial decomposition of dead algae decreases the amount of oxygen dissolved in the water. Low dissolved oxygen is a major cause of sucker die-off. A second type of blue-green algae, the toxic Microcystis aeruginosa, is found in the still, warm summer water behind Iron Gate and Copco dams, as well as to a lesser extent in Upper Klamath Lake. The toxin microcystin can harm humans, wildlife, and fish. Fishing, another factor that contributed to decreasing salmon populations, was overfishing. As technology developed, ocean salmon fishermen were able to take larger catches of mostly Chinook salmon. West Coast salmon trawlers peaked in the 1970s. Trawler numbers sharply decreased with declining salmon numbers and resulting complex government regulation. In the Upper Basin, Lost River chwam and short-nosed copto suckers, also called mullet, were harvested for food, oil, and fertilizer. Canneries were built, one in Olean on the Lost River, just east of Klamath Falls. Popular as a game fish in the 1960s, length, weight, and numbers declined sharply by 1978. The Klamath tribes closed their fishery in 1986 because the younger fish were not surviving. The Oregon Department of Fish and Wildlife closed the sucker or mullet fishery in 1987. In the last century, a greater understanding of the relationship between human impacts and the environment has developed. Just as humans can damage the environment, they can also improve the environment. Beginning in the 1960s, important legislation was passed to protect the environment, such as the Clean Air Act and the Clean Water Act. In 1973, the Endangered Species Act was passed. Klamath Lost River chwam and short-nosed copto suckers were listed as endangered under the ESA in 1988. Coho salmon were listed as threatened in 1997.